Welcome to Premath. In this video tutorial, we have got this big square of side length 8, and within that square we got another smaller square with side length 4, and moreover we have got this circle that is inscribed in this smaller square. And now we are going to calculate the area of this blue shaded region, as you can see in this figure. And in this video tutorial, I will show you two different methods to solve this given problem. So let's go ahead and get started with the solution. And keep in your mind the side length of this larger square is 8 units. And the side length of this smaller square is 4 units. And now let's focus on this line segment DC. Let me call this line segment, I'm going to represent it by X. And now we are going to find the value of X. That's going to make our job a lot easier. And here's our very first step. Let's focus on this smaller square, and we know that this side length is 4, isn't it? So we know that this is just the diameter of this circle is 4 as well. So the radius is going to be just the half of that one. So that means this part is going to be 2 and this is going to be 2. So therefore our EF distance is going to be 2 units, and we know that our DC is simply X. And now let's go ahead and calculate this FD distance. FD is this much, you know that thing. We know that this total side length of this larger square is 8. So this length is going to be simply 8 minus this 2 and then this minus X. So that is going to give us simply 6 minus X. So our FD value turns out to be 6 minus X. And now let's recall this two-tangent theorem. If two tangent segments are drawn to a circle from the external point, then the segments are equal, as you can see in this figure. And in our case, as you can see that this FD is one of our tangent to a circle, and the other one is this one, PD. Therefore, this PD equals to this line segment FD. So therefore, PD is going to be 6 minus X as well. And now let's focus on this EM. We know that this is 2 units as well. So then this length AM is going to be, we know the total side length of this larger square is 8. So this is AM is going to be simply 8 minus 2 is going to be 6. So therefore our MA value is 6. So according to two-tangent theorem, once again, this side MA is going to be equal to AP. Why? Because this MA is the tangent to a circle and this AP is tangent as well. So therefore our AP value turns out to be 6 as well. Now let's focus on this line segment AD. This is our AD is this much, and we can see that this is the sum of 6 plus and then this 6 minus X. That means AP plus PD. So therefore I can write AD equal to AP is 6 and plus PD is 6 minus X, and if we combine them, so our AD value is simply 12 minus X. Here's our next step. Let's focus on this triangle AED. And we know that this side of this triangle EA is going to be 8, since this is just the side length of this larger square. And moreover, this side length of this triangle ED is going to be simply 2 plus 6 minus x is going to give us 8 minus x. So thus our EA value turns out to be 8, ED is 8 minus x, and AD is simply 12 minus x. And since this is a right triangle, we are going to use this Pythagorean theorem. And here's the Pythagorean theorem: a square plus b square equal to c square. And in our this triangle AED, the longest leg is this AD. I'm going to call this side C. This horizontal side I'm going to call A. And this vertical side I am going to call B. And here's our Pythagorean formula: a square plus b square equal to c square, where a is 8 minus x, b is 8, and c is 12 minus x. Let's go ahead and fill in the blanks. So that's going to give us 8 minus x square plus 8 square equal to 12 minus x square. And now we are going to expand these binomial, this one and this one, by using this formula a minus b square. So that's going to give us 64 minus 16x plus x square, and that's going to give us 64 again, equal to 144 minus 24x plus x square. And we can see that this x square on the left hand side and this x square on the right hand side, they are gone. And if we combine the like terms on both sides and rearrange them, we end up with the 8x equal to 16, or simply x turns out to be 2, our value. So our x value turns out to be 2, as you can see over here. And now we are going to find the dimensions of this triangle AED. We know that EA equals to 8. As you can see, this side is 8. ED is 6. ED, this one, ED is, if we plug it in this x, we replace it this one by 2. 8 minus 2 is going to give us 6. And finally, this AD, this side, AD is 12 minus x is 2. So 12 minus 2 is going to give us 10. No wonder AD equals to 10. And here's the very first approach, the method that I'm going to show you. The area of this blue shaded region equal to the area of this whole big square ABCE minus the area of this unshaded right triangle AED. So let's go ahead and calculate the area of this square ABCE. And here's the area of a square formula: A equal to S square, where S represents the side length of the square. In our case, the side length is 8. So area is going to be simply 8 square. So that means area turns out to be 64. And now let's go ahead and calculate the area of this triangle AED. And here's the area of a triangle formula: half time base time height. In our case, base is simply 6 ED, this one 6, and this height is 8. So let's go ahead and fill in the blanks. So area turns out to be a half time base is 6 and height is 8. If we simplify that thing, that is going to give us 24. A turns out to be 24. So thus the area of this blue shaded region turns out to be area of this square ABCE. We just figured out 64. This is 64, and this minus the area of this triangle AED, which is 24. So if we simplify that thing, that is going to give 64 minus 24 is going to be 40. So thus the area of this blue shaded region turns out to be 40 square units. And here's our second approach, our second method. As you can see that this blue shaded region is nothing more than just the trapezoid A, B, C, D. We are going to find the area of this trapezoid A, B, C, D. And here's the trapezoid definition. It is a four-sided flat shape that has a pair of parallel sides, as you can see in this figure. Now let's go ahead and calculate the area of the trapezoid ABCD. And here's the area of a trapezoid. Formula A equals to A plus B times H divided by 2, where A and B are the sides of this trapezoid and H is the height. In our case, A is 8, B is 2, and this height H is 8. So let's go ahead and fill in the blanks. So area A equal to A is 8 plus B is 2 times H is 8 divided by 2. That is going to give us 10 times 8 divided by 2. That is going to give us 40. So A turns out to be 40. So the area of this blue shaded region is going to be simply 40. So thus 40 square unit is the area of this blue shaded region. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.